Welcome back, guys. We're going to dive straight into another investigation with Venn diagrams. And this time we're going to look at a problem that considers three different events. In other words, there are going to be intersections of three Venn diagrams, three separate diagrams intersecting, and we're going to have to do some calculations with that. So let's have a look at it. Here we have a survey that's taken place. There were 50 people in the survey, and they were asked if they'd ever broken the following parts of their body. They'd broken an arm, a leg, or a nose. The following data was established. We had 24 said they'd broken a leg, 16 had broken noses, 5 had broken an arm and a nose. Notice that 10 had not broken any of these body parts, 28 had broken an arm, 9 had broken an arm and a leg, and 6 had broken a nose. We're asked to draw a Venn diagram to determine how many had broken all three body parts. Yeah, that's quite a complicated little investigation. But you know what? If we take it one step at a time, we'll make sure that we'll get the answer. So our goal is to find where all three events overlap. I'm going to call the number in all three events X. So let's get going with that. So there we've got set L, set N, and set A. L standing for the leg, N for the nose, and A for the arm. And in the middle of this set, I'm going to say where they all overlap, I'm going to put an X over there. So the people that belong in that set, in that overlap, will have broken a leg, an arm, and a nose. They've broken all three. And that's what we want to try and find. We know that in total there are 50. So let's try and put some data from what was given onto the board here. So we know that the number in the sample set is 50. That's going to become important for us. We recognize that 10 had not broken anything. So there are 10 that sit here in the sample space. They're of those people that didn't break anything. Now, my approach to finding the others is to recognize that if you can look at the intersection of two things, you can add those in quite easily. So we recognize that 5 had broken an arm and a nose. So where we see nose and arm, we can put a 5 into that space. We recognize that 9 had broken an arm and a leg. So an arm and a leg, we're going to put 9 into that space. We recognize 6 had broken a nose and a leg. So nose and leg, we are going to put 6 into that space. Now, can you see what the next steps are going to be? Well, we're going to need to make sure that everything balances. And so we have got to be very careful here to recognize that the totals for each set now add up. And we've got 3 parts of every set. So be careful. You don't go and just enter data wildly. You've got to be thinking as you do it. So let me take you through that. The first thing that I recognize is that the total amount of people that have broken a leg. So remember, guys, this is the people that are in that whole set. That whole set comes to 24. So if I think about it, I would recognize that if they've only broken a leg, then they would sit into this space, okay, into that space there. We have got to recognize all of this adds to 24. But notice that what we've got here is 15 have already been accounted for. So if we take 24 minus 15, that will give us 9 left over. But we've also got to take away the X. So I'm going to say that's 9 minus X for the leg. And in a similar way, I'm going to be able to recognize what's happened for those that have broken a nose. we recognize that there were 16 in total. So all of these numbers add up to 16. Let me change the color of my pen so we can get it very clear. So there's the people that have broken their nose. The number in that sample is 16. We've got to recognize, though, that 11 of them are already counted and X. So what's left over, the people that only broke the nose, is 11. Sorry, not 11. I have made a mistake there. We've got the eraser here, just to erase that. It's 16 minus 11. 16 minus 11 gives us 5. But we've got to subtract X as well. So in this space, we're going to say it's 5 minus X. Wow, that's going to be quite interesting to look at. Let's look at our third set. And again, let's just change the color, and hopefully we can see that as the people that have broken the arm. So we had 28 in this set in total, and what we recognize is that 14 have already been accounted for. There's 9 of them, and there is 5 of them. So what's remaining of those people that only broke their arm must be 28 minus 14, which is 14 minus X, because the minus X is the people that broke an arm, a nose, and a leg. So we've got to make sure that we've set it up like this. Okay, can you see how we're going to be making progress? What do you think the next step is? Well, it's a simple arithmetic problem. In fact, we just have to add everything up and make sure that we get an answer. So let's give ourselves some space, and here we go. And so I've replicated the answer that I've drawn on the board, and I've put it into this arrangement over here. The only thing that I need to make sure that I also have is that I recognize that the number in the sample space is 50. Okay? And if the number in the sample space is 50, I can start to add some equations together. I'm going to add everything up and see that I can start to add things up to 50. And if we do that, we'll recognize we've got X in the middle, plus we've got 9, plus 6, plus 9 minus X. That was all in L. And then I'm going to say I've got plus 5 minus X, plus 5, and I recognize that that adds up already. I'm not going to add in the 6 because I've added in the 6 already, and I'm then going to say the only things that I've got left that haven't been added is 9 plus 14 minus X plus the 10, and all of this gives me 50. Now, if you add all of that together, what you will find is if you do the calculations, let's get the calculator out. We're going to add all the numbers together. So the 6, 5, and 9, I think you can see 6 and 5 is 15, plus 5 is 20, plus the 10 gives you 30. So we recognize we've got 30 to start with of just the numbers. So we have to add up to 50. So that means that the numbers with the letters all add up to 20. So I'm going to say the following. I'm going to say, I recognize I can make an equation I'm going to make an equation that says the following. 20 is equal to 9 minus x plus 5 minus x plus 14 minus x. Now, if I start adding all the things together, all the numbers together, that's 19 plus 9 is 28. So I'm going to subtract 28 from both sides, and I get 20 minus 28 is equal to minus x plus x minus x minus x. And if I add that together, this gives me minus 8. This will give me minus 2. x. And if I then solve for x, I can see that x is going to be 4. How about that? So it was quite a long, tedious calculation, but you know what? It's worthwhile sticking at it and practice these so that you make sure that you're getting them right. Let's see if we can do one more question on this follow-up. So they've asked us to look and see how many people have only broken a leg. Well, you know what? It's not difficult to see. In this case, only broken a leg is in that segment there. It means that we know that x is equal to 4, and we want to find 9 minus x, which is going to be what that is. We want to be able to find out what 9 minus x is. Well, that's simply 9 minus 4, so that's going to be 5. So the people that have only broken a leg would be 5. And so in the same way, you could calculate all the others of those that had only broken one thing. Right. Have a look at this. The probability that a random person that has taken the survey has broken at least one body part. Guys, this terminology, at least one, means that you have to consider all of those that are in the sets A, B, the neck, N, L, and A. So it's everything that's in that Venn diagram, except those ones that are in the sample space. Have a look here. So when we're looking at least one, we're considering all of this space. Because even though you've broken 3, you've broken at least one. Even if you've broken 2 of them, you've broken at least one. So all of these are included. The only people that aren't included are those ones that didn't break anything. So the ones that broke at least one is the complement of the intersection in that sense. So what we're going to do is we're going to say that those that have broken at least one is going to be the total number in the sample space, which was 50, and the number that did not break any, was 10. So the ones that are left behind at least one is going to be equal to 50 minus 10, which gives you 40, which is that whole space represented by the Venn diagram. Guys, I hope you can see that there are lots of other questions we could ask, but unfortunately, we need to go for a break. We'll see you after this.